To understand Pert charts, let's take a look at the software development life cycle. Now, we are not supposed to know much detail about the software development life cycle, but let's just take a look at the different phases that are involved in the development of a software. The first phase is requirement gathering. This is where you go and find out what requirements your client has, what kind of a software he wants. So this is where you gather all the information related to the type of software that the client wants to be developed. Then comes the analysis stage. You visit the premises, you take a look at how their system works initially, how is, for example, the attendance being taken, what kind of registers, manual paperwork they have, and you do your analysis at your client's premises to find out how their existing system works. Then comes the design phase. This is where you draw flow charts, you decide on the different modules, right, that are going to be included in the software. This is where you decide the programming language, perhaps. This is where you also decide what kind of testing or test data that you are going to eventually use. This is where you decide it, right? And then subsequent to that, you hand over these modules and the flowcharts to a programmer, and the programmer starts coding the software. Then comes the testing phase, and the testing, as far as the testing phase is concerned, testing can be of different types, right? We can have alpha testing, we can have beta testing, there's something called integration testing. So there are different kinds of testings. Some part of testing can be done in parallel with coding. Okay, some part of testing can be done in parallel with coding. So for example, your programmer has programmed a small module, a small part of the entire program has already so he's programmed a small part, a small module, and you can actually test that module even though the remaining modules have yet not been programmed. So you can test modules individually. There's this concept of unit testing where you can just test small pieces of program that have been written. So some part of testing can be done in parallel with coding. Not all testing, but only some part of testing can be done in parallel with coding. And I'm telling you this because in Pert charts we are going to see that there are some stages like coding and testing which can take place in parallel. Okay, after testing comes the phase of implementation, where you go to your client's office and you install that software at your client's premises. So the company is going to start using that software, right? And at this stage, the company is going to give its own feedback to you, because the software is now going to be run by the end users, the client's company. They'll give you a feedback, and that feedback is generally called acceptance testing. They can tell you, whether the software is working fine or there are some problems with this. So acceptance testing is also one kind of testing that takes place after the software has been implemented, after you have installed it on your client's computer. Okay, finally comes maintenance, and this basically means you developed a software 2 years ago, but the platforms have changed. You have Windows you had Windows 7 previously, now you have Windows 10. So you want to make sure the software you developed is compatible with Windows 10, so that is basically part of maintenance. Also, it is possible that your client may require for you to add some new features into the software, so that is basically also a part of maintenance. So I hope you understand that the software life cycle has several stages. Alright, now let's take a look at this table and see if the information that he has provided here. See, he said that we are going to use these labels for our activities. We are going to call our activity A, B, C or D. So we are going to be using these labels, right? And this is the amount of time it is going to take for an activity to complete. So for example, activity A is basically gathering requirements, right? And once you've gathered requirements, at the end you have a document which has all the requirements of the client inside of it. So this is the deliverable. So after collecting all the requirements, you come up with a document, or you produce a document that has a list of all those requirements. So this is the deliverable at the end. Okay, so this is basically what this is the design phase. It's going to take 2 weeks, and once again you'll have your flow charts and the other things ready after the end of the design phase. So these are the deliverables, right? Okay, now we have different activities, and for each activity we have the number of the number of weeks it's going to take, right? So for example, acceptance testing is going to take 2 weeks, documentation is going to take 4 weeks, right? And training users is going to take 3 weeks, right? So we have to draw a Pert chart for this. Let's take a look at the Pert chart that we can draw using the information that has been provided in this table. By the way, one final thing, when activity A has been completed, we've reached our second milestone. When activity B has been completed, we've reached our third milestone. So the completion of an activity results in reaching a milestone. Alright, so let's try and understand this Pert chart. But before we do that, remember, it's the job of the project manager to make this Pert chart, right? And this includes all the different phases and activities and milestones, and gives us information about how long some activity is going to take. So all of this information is basically the responsibility of the project manager. Okay, let's take a look at what this Pert chart is telling us. For example, right here it's telling us that activity A takes 1 week to complete, and once we are done with activity A, we have reached milestone 2. What this is also telling us is that activity B cannot begin until activity A has been completed. Until this has been completed, activity B cannot begin, right? So once activity A is complete, activity B is going to take 2 weeks to complete. Once we are done with activity B, milestone 3 has been reached. Okay, at the end of milestone 3, which we can see from our table is related to the design phase, the next 2 phases we can see are related to activity C and D. C is related to writing program code, and D is related to testing modules. And remember, a program code can be broken down into smaller parts, right? Subtasks or modules, and we can test those modules individually. For example, this is the program that we have to develop, and we can see that it is made up of 3 different modules, right? So it is possible that the programmer writes this module first. Once he has written this module, it can be tested also, right? So at this stage, the programmer has only written module A, and we can test it. Meanwhile, the programmer can develop module B. Whilst the programmer is developing module B, we are testing module A. So we can test it whilst the other modules are being developed, which basically means what? Whilst these modules are getting developed, the testing, the software testers can actually test these modules whilst the programmer is busy developing the other modules. Which means what? Which means that activity C and D are going to have an overlap, because we can test modules whilst the programmer is writing code. So the programmer, once he completes a certain small module, we can test it, and the programmer can meanwhile start coding other modules. So there's going to be an overlap between C and D. And we can see that information on the Pert chart also. We can see that whilst activity C is taking place, where the programmer is writing code and it's going to take 8 weeks, activity D can take place in parallel, which is related to testing the modules that the programmer is developing. So these two activities can take place together. Remember so activity D and activity C can occur in parallel, right? These two can take place in parallel. However, activity E can only get started once activity C has been completed. And when we take a look here at activity E, it says integration testing. And what is integration testing? Basically, the programmer, once he has written all of these modules A, B and C, we package them in one place. So A, B, C, collectively, this is our program code, right? This is our program code. And now we can check the entire code collectively. Okay, so integration testing involves all the modules that are part of the code, and we package them, and we see that these modules are interacting well with one another. The software is working well with all the three modules in place, right? So that is integration testing. It can only take place after all the modules have been developed. So we are able to package that entire software, and now we can test that software collectively. Which basically means what? That this phase related to integration testing takes 2 weeks, and it can only take place after the entire program code has been written, which means after activity C has been completed, then we can start activity E. And activity D, as you can see here, is also finishing at the same time. We have tested our modules independently, individually, right? So this activity D can finish at the same time that activity E is finishing, which means that testing of individual modules as well as integration testing can finish at the same time. Okay, but what we should realize here is that we had a total time of about 8 weeks here and 2 weeks here, 10 weeks, and we only required 5 weeks for module testing, which basically means we had lots of spare time, right? And this spare time that we had for activity D is called, the spare time that we had, right, is called slack. It is called slack. We can also see here that activity H is taking place in parallel with activity E. Whilst we are doing our integration testing, we can also start working on activity H. And activity H, as you can see here, is related to writing documentation, technical documentation about how the software works, right? About how different features in the softwares work, right? So the technical documentation can be done in parallel with integration testing. Okay, once this technical documentation is over, it takes 4 weeks. We've reached milestone 9, and you can see this dotted arrow here, which is basically indicating that this is a dummy activity. Okay, so we're basically not doing anything here. Right? Now what this Pert chart is also telling us is that activity F can only begin after activity D and E have been completed. Meaning what? Meaning D was related to testing modules and E was related to integration testing. Once this testing is over, only then can we go to activity F, right? And activity F, as you can see here, is related to the installation of software at, for example, your client's office, right? So obviously activity F can only take place after activity D and E, which are related to testing, have been completed, right? So this makes perfect sense that activity F can only take place after activity D and activity E have been completed. Okay. Next we can see that we have two activities, activity J and activity G, which are taking place in parallel, and both of these activities are taking 2 weeks. And as we can see here, G is related to acceptance testing, which means now that the software has been installed at your client's premises, the people working at the office are going to run that software. They are going to give their feedback to you, tell you whether it's working fine, it is working up to their expectations or not. So that is acceptance testing. And as acceptance testing is going on, meanwhile at the same time activity J, which is related to writing training material on where you want to train the people working at your client's office, these two can take place in parallel, and both of them require 2 weeks. And finally activity K, which can take place after both G and J have finished. This is related to training the users, and this is going to take 3 weeks. Once this training has been complete, now the software can go live, which is going to take 1 week. And by live we mean now the people at the office can start entering real data that is relevant to their office work. Previously they had been working with experimental data just to see how the software was working, but now they can start inputting actual details into the software, and the software can start and they can start running the software. Okay, hopefully you've understood Pert charts. And finally there is something called the critical path. There is something called the critical path. And what do we mean by critical path? It is the longest possible time that from start to end. For example, we go this way, 1 plus 2 weeks is 3 weeks, plus 8 is 11 weeks, plus 2 is 13 weeks, this is 14 weeks, and we can go this way, 16 weeks, 19 weeks, and 120 weeks. So this longest possible path from start to end is the critical path. Okay, so we could have had if we were to choose a shorter path, for example, if we were to choose something like this, for example, then this would not be the critical path. Okay, this would not be the critical path. So this is not the critical path. The critical path is the path that takes the longest amount of time. 1 plus 2 plus 3, 8, 11, 2, 13, 14, 16, 19 and 20 weeks in all. So what we are basically saying is, once we have chosen the critical path, what we are basically saying is that this project will take 20 weeks to complete. Does that mean that the project will really complete in 20 weeks? Well, sometimes there can be delays, but this is at least this much time is going to be required to complete the project. So any delays in any of the activities that are part of this critical path, right? For example, activity C is delayed by 2 weeks. That will eventually do what? That will eventually delay the completion of the project, right? So these activities that are part of the critical path must be completed on time for the project to be completed within 20 weeks.